differentiation in that exercise 1.5. The first example is find the second order derivative of the following functions. First 2x raised to 5 minus 4x cube minus 2 upon x square minus 9. So let y is equal to the given function. So differentiating with respect to x, what we get, dy by dx is equal to 2 is a constant, so 2 into d by dx of x raised to 5 minus 4 into d by dx of x raised to 3 minus 2 into d by dx of x raised to minus 2, because it is 1 upon x raised to 2, so we can take it at the numerator by x raised to minus 2 using laws of indices, and then d by dx of 9. 9 is a constant, so its derivative is 0. Then derivative of x raised to 5 is 5x raised to 4. Derivative of x cube is 3x square. Derivative of x raised to minus 2 is minus 2x raised to minus 3. So the derivative we got it as dy by dx is equal to 10x raised to 4 minus 12x square plus 4x raised to minus 3. Now again differentiate this function with respect to x. Then we get d by dx of dy by dx. So 10 into d by dx of x raised to 4 minus 12 into d by dx of x square plus 4 into d by dx of x raised to minus 3. So the d by dx of dy by dx means d2y by dx square. Then derivative of x raised to 4 is 4x cube. Derivative of x square is 2x. And derivative of x raised to minus 3 is minus 3x raised to minus 4. After simplifying, you will get d2y by dx square is equal to 40x cube minus 24x minus 12x raised to minus 4. This is the derivative of the given function. Let us move further. The second problem is e raised to 2x tan x. So let y is equal to e raised to 2x into tan x. Now differentiate this function with respect to x. Now here there is a product of two functions, so you have to use the product rule. dy by dx is equal to e raised to 2x into d by dx of tan x plus tan x d by dx of e raised to 2x. So first function as it is, derivative of the second function, plus second function as it is, derivative of the first function. Now you can take e raised to 2x common from this. So dy by dx is e raised to 2x in bracket x square x plus 2 tan x. Now again differentiate this because we want to find the second order derivative. That means we have to differentiate twice. So d by dx of dy by dx, again differentiating, again you have to use the product rule because here there is a product of two functions. First function as it is, derivative of the second function, plus second function as it is, derivative of the first one. Okay, so find the derivative of sec square x is 2 sec x into tan x, because you have to use the f of x square. Its derivative is 2 f of x into f dash of x. Derivative of tan x is sec square x. Here is also derivative of e raised to 2x is e raised to f of x is e raised to f of x into f dash of x. Use that formula, you will get take e raised to 2x common from these two factors. Then sec square x tan x plus sec square x plus sec square x plus 2 tan x. Now sec square x plus sec square x, you will get 2 sec square x. Okay, and from these sec square x, I will take 1 sec square x common. So in bracket we get tan x plus 2 and this 2 tan x. So the derivative of the given function is d2y by dx square is equal to 2 e raised to 2x in bracket sec square x in bracket tan x plus 2 plus 2 tan x. This is the derivative of the given function, second order derivative. Next problem, e raised to 4x into cos of 5x. Let y is equal to e raised to 4x into cos 5x. Differentiating with respect to x, again we have to use the product rule. First function as it is into derivative of the second function plus second function as it is into derivative of the first function. So derivative of cos of f of x, you have to use cos of f of x is minus sin f of x into f dash of x. F dash of x means derivative of 5x, but derivative of 5x is 5. Similarly, e raised to f of x, its derivative is e raised to f of x into f dash of x. So f dash of x means derivative of 4x is 4. So 4 e raised to f of x. I take e raised to 4x common. Then what you get? 4 cos 5x minus 5 sin 5x. Now again differentiate this function with respect to x. First function as it is, derivative of the second function, plus second function as it is, derivative of the first one. Then find the derivatives of these functions. What you get? d2y by dx square is e raised to 4x as it is. D by dx of cos 5x is minus 5 sin 5x. Derivative of sin 5x is 5 cos 5x. And derivative of e raised to 4x is 4 e raised to 4x. Then multiplying the corresponding coefficients, we get minus 25x minus 25 cos 5x plus 4 cos 5x minus 5 sin 5x. Okay, then we will take e raised to 4x common. Okay, then this factor will as it is, and we have to multiply this second factor by 4. 4 4s are 16 and 5 4s are 20. Then minus 20 sin 5x and minus 20 sin 5x is minus 40 sin 5x. Minus 25 cos x plus 16 cos 5x will minus 9 cos 5. So this is the derivative. d2y by dx square is minus 4 is to 4x plus 40 sin 5x plus 9 cos 5x, because we have taken minus common. The fourth example is x cube log x. So let y is equal to x cube log x. Now differentiating with respect to x, first d by dx of x cube log x. So first function as it is, derivative of the second function, plus second function as it is, derivative of the first function. So here if you cancel this a1x, x square will remain, and we will write this as a 3x square log x. So again differentiating with respect to x, d by dx of dy by dx is nothing but d2y by dx square, then d by dx of x square plus d by dx of 3x square log x. So here you have to use product rule. 3x square as it is, d by dx of log x plus log x as it is, d by dx of 3x square. Now the derivative of log x is 1 upon x and derivative of 3x square is 6x. This again 1x will cancel and 3x will remain. 3x plus 6x log x. Now 2x plus 3x is 5x, and we can take 1x common. So x times 5 plus 6 log x is the second order derivative of the given function. Y next function y is equal to log of cos x. Now differentiating with respect to x, we have to use composite function rule. D by dx of log x. So log of f of x is 1 upon f of x into f dash of x. Now what is f dash of x? Means d by dx of log x. Its derivative is 1 upon x. So I can write it as dy by dx is 1 upon x log x. Again differentiating with respect to x, we have to find derivative of 1 upon x log x. We will use the formula 1 upon v. Now derivative of 1 upon v is minus 1 upon v square into dv by dx. So dv by dx means the derivative of x log x. There is a product of function. So first function as it is, derivative of the second function, plus second function as it is, derivative of the first function. So derivative of log x is 1 upon x and derivative of x is 1. So what we get? 1 plus log x. So minus 1 upon x log x bracket square into 1 plus log x. So we can write it as d2y by dx square is equal to minus bracket 1 plus log x upon x log x bracket square. This is the second order derivative of the given function. moving further, the next example is x raised to x. So as y is equal to x raised to x, it is a function raised to function. So you must click which method we must follow to solve find the derivative of this function. Okay, logarithmic differentiation. So taking logs on both the sides, taking log of both the sides, log of y is equal to log of x raised to x. Now using the index property, I can write it as x log x. Now we will differentiate it. D by dx of log of y is equal to d by dx of x log x. Now here log of y with respect to x, we are finding the derivative with respect to x, but here there is no x. So firstly we have to differentiate with respect to y and then y with respect to x. So 1 upon y dy by dx. Now here first function as it is, derivative of the second function plus second function as it is, derivative of the first function. So dy by dx is equal to this. So find the derivative. You will get the answer x raised to x in bracket 1 plus log of x. Now again differentiate the function because we want to find second order derivative. So again there is a product of function y as it is, d by dx of second function plus second function as it is, d by dx of first one. So y as it is 1 plus log x, its derivative. Derivative of 1 is 0 and log x derivative 1 upon x. Again d by dx, so dy by dx. But we know that dy by dx is x raised to x 1 plus log x. So put that value here. So y by x plus something. This y is nothing but x raised to x. So put the value of x raised to x. I take this x to the numerator, x raised to minus 1. So x raised to x into x raised to minus 1. It becomes x raised to x minus 1. And the remaining term as it is 1 plus x times 1 plus log of x bracket square. Again d2 y by dx square, but at it is given x is equal to a times theta minus sine theta and y is equal to a 1 minus cos theta. Now here x is expressed in terms of theta and y is expressed in terms of theta. So here we have to use the parametric differentiation. Now take y and differentiate with respect to theta. A is a constant, so we have to find only derivative of 1 minus cos theta. So derivative of 1 is 0 and derivative of cos theta is minus sin theta. So we get dy by d theta is equal to a sin theta. Similarly, x is equal to a theta minus sin theta. So we can find its derivative. Differentiate with respect to theta. A is a constant. Now derivative of theta is 1 and derivative of sin theta is cos theta. So dx by d theta is a in bracket 1 minus cos theta. Now use the parametric differentiation. Dy by dx is dy by d theta upon dx by d theta is nothing but dy by dx is equal to a sin theta upon a in bracket 1 minus cos theta. Put the values of the derivatives that we have obtained. Now this sin theta can be written as 2 sin theta by 2 into cos theta by 2 using half angle formula. Also 1 minus cos theta can be written as 2 sin square theta by 2. So 2 cancel. This sin theta by 2 sin theta by 2 also cancel, and cos theta by 2 upon sin theta by 2 is cot theta by 2. This is the derivative of the y. Dy by dx. Again differentiate this function with respect to x. So differentiating d with respect to x, we get these 2y by dx square is equal to d by d theta of cot theta by 2 into d theta by dx. So here the function is in theta and we are differentiating with respect to x. So firstly we have to differentiate with respect to theta and then theta with respect to x. That is chain rule. We have to use here chain rule. So minus cos x square theta by 2 into d theta by d theta of theta by 2. That means the cot of f of x. Its derivative is minus cos x square f of x into f dash of x. And derivative of the inverse function using that formula d theta by dx can be written as 1 upon dx by d theta. And what is dx by d theta? This is a in bracket 1 minus cos theta. So simplify it. We get minus cosec square theta by 2 into 1 upon 2 times this. So 1 upon 4a cosec raised to 4 theta by 2 is the derivative of this function. Second order derivative. In this exercise, we are just finding the second order derivative of the given function. Now again, the same parametric functions are given, x in terms of t, y in terms of t. So t is the parameter. Take y is equal to 480 and differentiate with respect to t, we get 4a. Similarly, take x is equal to twice 80 square, differentiate with respect to t, you will get derivative as 480. Okay. This is the way that we are differentiating using parametric differentiation. If you don't want to go to differentiate this parametric by parametric, you have to find the functional relationship between these two variables x and y. Now, how to find the functional relationship, that we have to decide. We have to put the value of y in terms of x or x in terms of y. Now here is t square and here is only t. So is it possible to write this twice 80 as 480? We can write it as, because here we will multiply divided by 2a. So here it becomes 4a, then again multiply divided by 4. So that I can write it this function as 480 bracket square, and then I will replace it by y. So I can directly differentiate with respect to x. Now here I am explaining by using parametric differentiation. So first derivative is 1 upon t. Then differentiate with respect to t, d by d, no, differentiate with respect to x, it's right. Then d by dx of dy by dx is d by dx of 1 upon t. Now here in left hand side we will get d2y by dx square. But here the derivative with respect to x and function is in terms of t. So we cannot differentiate directly with respect to x. We have to use chain rule. Firstly, we have to differentiate it with respect to t and then differentiate t with respect to x. Then we have to use the inverse differentiation. We can write dt by dx as 1 upon dx by dt. But what is 1 dx by dt? 480. So we will put that value here, 480. And we get the derivative as minus 1 upon 480 cube is the derivative of this function. The third example is x is equal to sine theta, y is equal to sine cube theta, and we have to find the second derivative at the point theta is equal to pi by 2. What is given? Y is equal to sine cube theta. Differentiate with respect to theta. Here you have to use f of x raised to n is n times f of x raised to n minus 1 into f dash of x. So dy by d theta is 3 sine square theta into cos theta. Similarly, find the derivative of x is equal to sine theta. Its derivative is dx by d theta is equal to cos theta. Now use parametric differentiation and find dy by dx. It is comes out to be 3 sine square theta. Now differentiate this with respect to x. We cannot differentiate directly with respect to x, so you have to differentiate it with respect to theta and then theta with respect to x. And for this d theta by dx, we have to use the derivative of the inverse function. We can write it as 1 upon dx by d theta, and we will put dx by d theta, its value is cos theta. So cos will cancel and you will get the derivative as 6 sine theta. But we want to find the derivative at particular point theta is equal to, for the parameter theta is equal to pi by 2. So we will put theta is equal to pi by 2 in this derivative. Now sine 90 is 1. So 6 into 1 is 6. So derivative is 6. Now the next example is x is given a cos theta, y is given b sine theta, and the parameter theta is pi by 4. Take y, differentiate with respect to theta. Similarly, take x, differentiate with respect to theta. Use parametric differentiation to find the derivative dy by dx. It comes out to be, So the dy by dx is minus b by a cot theta. Again differentiating with respect to theta. No, with respect to, then we get d by dx of dy by dx is equal to minus b by a is constant, d by dx of cot theta. But d by this is the second order derivative, d2y by dx square is equal to minus b by is a constant, and this cot theta is in terms of theta, and we are differentiating with respect to x. So firstly we have to differentiate with respect to theta and then theta with respect to x. This d theta by dx can be written as 1 upon dx by d theta, and derivative of cot theta is minus cosec square theta, and the dx by d theta, its value is a minus a sin theta. So put that here. Now this a and this a, it becomes a square, and this 1 upon sin theta is cosec theta. So here cosec square theta into cosec theta is cosec cube theta. So the answer we get is d2y by dx square is equal to minus b by a square into cosec cube theta. But we want derivative at theta is equal to pi by 4. So we will put theta is equal to pi by 4 in this equation, and we get the derivative. Cosec cube of pi by 4 is nothing but root 2. Cosec pi by 4 is root 2. So root 2 its cube is 2 root 2. Root 2 cube is 2 root 2, and this b upon a square. So this is the derivative of the given function at given point.